Hello, chemistry students. We're going to do the introduction to isotopes right here. And at the end of about 3 or 4 minutes, you should know what the heck isotopes are and what the role they play in chemistry. So here goes. The element I'm going to start talking about is carbon. And got the whole carbon atomic symbol up here. Its atomic number, which I know you know means how many protons every single carbon atom the whole universe over has. In fact, if it doesn't have 6 protons, it's not carbon. That's kind of it right in the DNA. So, all right, that's one thing about carbon, the atomic number. And down here we have this other number you'll see in the periodic table, 12.011. Well, that's known as the atomic mass. All right. Well, that number tells us that if you had 12.011 grams of carbon, well, you'd have 1 mole of carbon. I haven't talked about the mole yet, but hey, it's a really important number we'll get to in just a bit. But basically, the atomic mass is telling you how much a certain number of atoms would weigh. Okay, well, here's the part about isotopes. I have one of them hidden right behind me here, and isotopes are all atoms of, like in this instance, carbon, but they all have the same number of protons, but they have different numbers of neutrons. That's the big difference. Now, you can have isotopes of any element. I'm just using carbon as a for example. There's isotopes of hydrogen and uranium and fluorine and all the rest. But here we go. So, this is how much all the mixtures of carbons together, different types of isotopes would weigh. But let's take a look at what those mixtures are about. In this particular drawing I have, if you can zoom in here, you see you have 1, 2, 3, 4, 5, 6 protons with their positive charge. And they also have 1, 2, 3, 4, 5, 6 neutrons there in the center with neutral, no charge at all. I only have a couple of electrons zipping around this atom, but we'll talk about electrons later on. So for right here, we see that this atom of carbon has 6 protons and 6 neutrons. If you add those 6 together plus these 6, you have 12 total subatomic particles in the nucleus. And hey, the neutrons and protons, they're the ones that have all the mass. So this particular isotope of carbon is known as carbon 12. Where's that 12 coming from? 6 protons, 6 neutrons. All right. Well, there are other carbon atoms out there. If you were to dig up a bunch of carbon, maybe coal, and look at all the different carbon atoms there, you'd find that a whole lot of them have 6 protons and 6 neutrons. Okay, well, you'll also find some that have 6 protons and 7 neutrons. Well, let's just turn this one into carbon that has 7 neutrons. And as soon as I do that, it won't be carbon 12 anymore. 1 more neutron, and now it's 6 protons, still carbon, but 1, 2, 3, 4, 5, 6, 7 neutrons. 7 plus 6, grand total, 13. All right, this is carbon 13. Still carbon, different number of neutrons. All right, and hey, there's even something called carbon 14, which if you've heard about radiocarbon dating and having scientists find out how something is thousands of years old, well, carbon 14 is a special isotope that plays a role in that, but hey, we'll talk about that later. Getting a bit sidetracked. It's super exciting. So here is carbon 13 with 7 neutrons and 6 protons. When you get to carbon 14, I bet you know how to get there already. Yep, we can't change the protons. We can change the neutrons. So if I do this, whoop, 1 more neutron, 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 6, that's a grand total of 14. So that we just saw 3 different isotopes of carbon. We had carbon 12, carbon 13, and carbon 14. They all exist. Those are the 3 different varieties of carbon that's out there. And here's some really important thing I want to share with you next. What you see here is a weighted average. If you took an average of all the carbon elements out there, atoms out there, and you weighed them all up and divided them by their mass, what they weighed, you'd find that on average, they weigh really close to 12. Now, what that's telling you, that's what tells me, is that there are way more carbon-12 isotopes out there. They're the most common ones, and the carbon-13 and carbon-14 are pretty rare. Because when you average them out, hey, we're down to 12.0, almost 12, but hey, 0.011. The extra neutrons of carbon-13 and 14 tilt that average just a bit more than 12. So you can look at any elements in the periodic table and you look at their atomic masses, you kind of get an idea that that's an average of all the different isotopes. And wow, are there all kinds of ways that humans can use the knowledge of isotopes to figure out crazy puzzles. That radiocarbon dating, that's just one thing. It goes on and on and on. One of them that comes to mind is I've read articles about how they can measure the isotopes of calcium in your teeth, or even like long dead people, and find out what they had for dinner, what was in their diet. What? It seems like it's not even true, but it's a science fact, and you can do that with your knowledge of isotopes. So in conclusion, what are isotopes? Isotopes are the types of elements that have the same number of protons, but different numbers of neutrons. Every element is an isotope, it's just what isotope is it? And that's the big idea. Hope that was helpful. See you back in class tomorrow.